In this video, we're talking about adding integers, not only numerically with numbers, but also pictorially and with manipulatives. The materials you'll need for this include a number line, not only showing the whole numbers, but also negative integers as well. Counters, both positive and negative. And the last thing you'll need is a math frog, because you're going to be teaching your frog how to do math on a number line. Now, when teaching your math frog how to do math, the most important thing to remember is your math frog always starts out at 0. Sometimes we refer to 0 as the origin, because that's where we begin the equations from. Notice also our math frog is pointing towards the positive side of our number line. That's because he's a happy frog right now. So when you're adding integers, your math frog will always point towards the positive. Now, even though our frog is a math frog, I'm going to let you in on a little secret. He actually doesn't know any math yet, because you need to teach him the math. So let's start off with a very basic expression to solve. The first expression that we're going to teach our math frog how to solve is 2 plus 3. The first number in our expression, the number 2, is telling us where we need to move our number frog. Unfortunately, our number frog has very short-term memory. Therefore, we'll need to use counters to keep track of where he has traveled from. Since our function is addition, and our second add-in is positive, we're going to continue moving our frog forward 3 place values, keeping track of where he has been using counters. This is a rather simple expression, and of course the solution for this expression is 5. Now let's take a look at an example when both add-ins are negative integers. For this example, notice that the second add-in is in parentheses. That's because it's negative, and we put it in parentheses just to kind of highlight the fact that it is negative. Also, we don't want to confuse this with the function of subtraction. Like our previous example, the first add-in will tell us where to move our frog first. And like before, we'll be using counters to keep track of where our frog has been. However, this time we'll be using our negative counters because our integer is negative. Continuing with our expression, our second add-in is negative, so we're going to continue moving our frog backwards 3 place values. Remembering to keep track of his progress with counters. As you can see, the solution for this expression is -5. For the first 2 examples shown, both integers were either positive or negative. Now, when you have both positive or both negative, use the common sign for the sum. What does that mean? Simply add the absolute value of both add-ins, and if both add-ins are positive, your sum will be positive, and if both add-ins are negative, your sum will be negative. Now let's take a look at an example where both add-ins are not both positive or both negative. As you can see, we have an example here where one add-in is negative and the other add-in is positive. The first add-in will tell us where we need to move our frog to, and like the previous examples, we need to keep track of his path, this time using our negative counters since our first add-in is negative. Since we are adding and our second add-in is positive, we are going to be moving our math frog forward 3 units. Meanwhile, keeping track of his progress using the positive counters. As you can see here, we have a set of positive counters with an equal set of negative counters. When we have this, this is called a zero pair, and when you combine these positive counters with negative counters, they equal 0. Of course, once we get rid of our zero pairs, the only thing we have left is simply one counter, which happens to be the solution for this expression. We could also use commutative property to rewrite this expression. The commutative property of addition allows us to switch the first add-in with that of the second add-in. Keep in mind, though, you need to keep the same integers. Therefore, that second add-in there is going to be a -2 because in the prior expression it was also a -2. Let's look at one final example here, a positive plus a negative. First number again is going to tell us to move forward 2 place values, and we'll keep track of that with our positive counters because it's a positive integer. Then the second step, we're adding a -3, so we're actually moving backwards, and we're going to keep track of that with our negative counters, our red counters. Here we can see we have a set of 0 pairs, so we can take those out. And what we're left with is simply one negative red integer. So that's our solution there, is -1. Again, we could rewrite this using commutative property. So it would be -3 plus 2. That will give us the same results on the number line. With the previous two examples where one add-in was positive and the other add-in was negative, you need to take advantage of the absolute value. If the negative add-in has a larger absolute value, then the sum is going to be negative. However, if the positive add-in has a larger absolute value, then the sum is positive. Either way, you need to subtract those two add-ins. So for instance, -10 plus 4, I have to subtract those two. So 10 minus 4 is 6, and because 10 has a greater absolute value, my answer will be -6.